Hey all, welcome back to another video. Today's first question is, how many positive integers less than 1,000 are divisible by 2 and 3 but not 5? So our path to do this is basically first finding the LCM of 2 and 3. So LCM 2, 3, dividing the LCM of 2 and 3 from 1,000, and then getting rid of all the numbers in between that are also divisible by 5. So of course we can't actually just pick them all out. So you know that LCM 2, 3 is 6. You're going to divide 1,000 by 6. First 1, 6, 4, 0. You're going to get a 6. You're going to get 36. You're going to get a 4. Move it down again, you get another 6. So basically, there are 166 numbers that are divisible by 6 that are less than 1,000. So there's 6 times 1. 2, 6 times 166. So as you can see, there are 166 of them because 166 minus 1 plus 1 is still 166. So we're not done yet though because we still have to filter it out for 5. And we know that 5 is basically, if a number is divisible by 5, the rule of divisibility for 5, that it either ends in a 5 or a 0. So we can basically cut out because the first one that gets a 5, that's also a multiple of 6 is 6 times 5. The second is 6 times 10, so on, so on. You can notice that now there's a pattern of 5, so we divide 5. So we go 166 divided by 5. And you're going to get 3 on the top here, 15, 1, 6, another 3. So there are 33 numbers that are also divisible by 5 in our 166 numbers. So we're basically now going to minus how many that are divisible by 5 from the total number. So 166 minus 33. 166 minus 33. It's 133, which is also our final answer. Moving on to problem number 2, the lockers in my school are numbered in order from 1 to 1,000. Initially, they are all closed. There are 1,000 students in my school. The first student goes through the school and opens every locker. The second student goes through in the school, and for every second locker, if the locker is closed, she opens it. If the locker is open, she closes it. Third student does the same for every third locker. The fourth does the same for every fourth locker, and so on until all 1,000 students have gone through the school. After all the students have finished, how many lockers are open? So, this problem is more of a twist on your mathematical formulas. So for the visual learners here, say that there is 1,000 lockers here, okay? So there are 1,000 lockers, 1,000 lockers. Or these box things. So say that we randomly pick a locker from somewhere in the middle here. So like random locker, okay? And this locker, how many people go and open it and close it is also equivalent to how many factors it has. So say 8. The people who open and close it are going to be the people who go as the factors of 8. Like 1, 8, 4, 2, so on, so on. So taking that idea, you know that all numbers factors come in pairs. So let's use 8 again. So 8 has the factors of 1 and 8. These two come as a pair. And they also have 2 and 4. These two also come as a pair. So saying that it stops there, we can see here that there is an even number of factors that 8 has because they come in pairs. However, you can also notice, try this yourself if you want, that if it is an even number, if an even number of people touch the locker, then it's going to be closed in the end because 1 opens it, 2 closes it, 4 opens it again, and 8 closes it again because it's an open, close pattern if it has an even number because it comes in pairs, as I said. So taking that idea, that means that we need to look for the numbers that have an odd number of factors. And unfortunately, 8 is not one of them, but moving on. We know that since perfect squares, say 64 is perfect square, so 64 starts like 8. It has 1 and 64, and 4 and 16, and so on, so on. But the one part of 64 that differs from 8 is that since it is this perfect square of 8, it only writes 8 once in its factors, and there is no second 8 student to open and close the locker again. So that means that the 8 is going to throw off the entire pattern and leave it open. So taking that idea, since all perfect squares have this idea where they are the perfect square of a certain number and only one student is corresponding to that number, we're basically going to try worming out all the perfect squares in order to see how many lockers are still open. So let's see here. There's obviously the first perfect square, which is 1. And that is the 1 times 1. And now we're looking for the one that gets you barely to under 1,000. And we know that the perfect square of 32 is 1024. Actually, you might not know, I learned that just yesterday, but whatever. It's 1024, so that means we're looking for something slightly under that, which would be 31's perfect square. So that means that there are 31 perfect squares from 1 to 1,000, which is actually quite a lot less than you might expect, actually, but So that means that there are 31 lockers that are still going to be open after this entire ordeal is over. So yeah, that's the end of this video. I hope you guys enjoyed it. I hope you guys learned something new. And I'll see you guys on the next one. Bye!